Now we shall see for the same problem how to solve using preemptive priority scheduling algorithm. Preemptive priority scheduling algorithm. So you already know what is preemptive priority. That is, preemptive means you need to stop the process based on certain priority. Or now, as you have seen already, you have come across your SJF and SRTF algorithms plus your FCFS algorithm. So in your SJF and SRTF algorithms, based on the arrival time, you were solving your preemptive, that is your shortest remaining time first algorithm. Based on the arrival time, you were pausing the processes to execute. Now you need to consider the arrival time plus the priority given in the question. Both the things you need to keep in mind and then write your Gantt chart. The first step, as you are aware, is how to write the Gantt chart. So now when you write the Gantt chart, here we are going to see the arrival time. So what is the arrival time? The starting arrival time is 0. So when the time was 0, process P1 has arrived. Process P1 has arrived. And the burst time or the complete milliseconds required for P1 to execute is 10 millisecond. Now, since it is preemptive priority scheduling algorithm, I need to see that how to compare or within 10 milliseconds are any other processes coming into the CPU. If in case those processes are coming, then I need to check the priority also. So now what I'll be doing is, I know that the time required for process P1 is 10 milliseconds. But when the time is 1, process P2 is coming into the queue. And now when process P2 is coming into the queue, I need to compare its priority. What is the priority given for process P2? So if I see the priority of process P2, it is 1 and process P1 priority is 3. Always remember, when you are solving your priority scheduling algorithm, lowest number will have highest priority. Lowest number will have highest priority. So now what you need to do is, you need to stop or pause process P1 and give importance for process P2 to execute. Why? Because it is priority scheduling algorithm. Based on the priority, you are going to solve the problems or schedule your processes. So at time 1, process P2 has come with least priority, that is the lowest priority when compared to process P1. So 1 minute process P1 will execute. Next, automatically process P2 will start its execution. So now when process P2 starts its execution, I will see the burst time. Burst time is only 1 millisecond. So complete 1 millisecond I will give. If I give complete 1 millisecond, the time will be 2. 1 plus 1 equal to 2. When the arrival time is 2, the process P3 comes into picture, but its priority is 4, which is higher than the process P2 priority. So I can ask process P2 to complete its execution and go away. So now if you see here, since the burst time is 1, process P2 has executed and it's complete and it has gone out of the CPU. Now the remaining processes are P1, P3, P4 and P5. Now I'll be comparing with its priority. Now process P3's priority is 4. But already I know that process P1 has come into the Gantt chart, or it is already executing. It is being paused. So what I will do, I will ask or compare process P1 and process P3's priority. If I compare process P1 and process P3's priority, P1's priority is less. It is having lowest number 3. So what I am going to do now, I will ask process P1 only to execute. Process P1 to execute. I repeat once again, when time is 2, process P3 is coming into the queue or into the CPU, but process P3's priority is 4, which is higher than process P1 priority. So what I will do, I will give importance for process P1 to execute. So I will ask P1 to execute. I will be checking for next how many milliseconds it can execute. Now as of now it has executed for only 1 millisecond. So the total remaining time is 9. Now I will see if I give next 1 millisecond. So when time is 3, process P4 is coming into picture again. When time is 3. So when time is 3, process P4 is coming into picture, but its priority is 5. Process P4's priority is 5. So compared to process P1, process P4 priority is greater. So what I will do, I will ask process P1 only to execute for 1 more millisecond. That is next 1 millisecond. So if I ask it to execute for next 1 millisecond, the time will be 4 milliseconds. So next 4th millisecond, process P5 is coming into picture. When process P5 is coming into picture, I will again compare its priority. Its priority is 2. Now when I see that I have given now 3, 4. So 2 plus 2 is 4. That is 2 milliseconds I will be allotting to process P1 to execute. Now when time is P4, I see that, when time is 4 millisecond, I see that process P5 comes into picture with least priority 2. 2 is less than 3. Now I will ask this process P1 to pause. I will see to that it will execute for next 2 millisecond. That is total remaining time will be 7 for P1 process. And now I will ask process P5 to execute. P5 to execute. So P5 will be executing for next 5 milliseconds. So next 5 milliseconds it will execute. Why? Because there are no other processes given in the question. All the processes have come into picture. P1 is there, P3 is there, P4 is has also come into the picture. So P5 will be executing for complete 5 milliseconds. So it will be 4 plus 5 equal to 9. Next, after now P5 is over, P2 is over. Remaining processes to be executed are P1, P3, P4. Now I will be comparing its priority. So P1 priority is 3, P3's priority is 4, P4's priority is 5. So least number is 3. So complete seconds I will be asking P1 to execute. That is 9 plus 7. 9 plus 7 equal to 16 milliseconds. It will execute for next 16 milliseconds. Now even P1 has completed its execution. Next I will compare P4 and P3. When I compare here, P4 is having least value. So P3 will execute for 2 milliseconds. That is 16 plus 2 equal to 18. Last process will be P4. That will be executing for next 1 millisecond. Next